Are you tired of reading textbooks? Is dissecting a frog more than you can take? Well, here's the perfect opportunity to do something you want to do and at the same time make a finished product that you can be proud to show off. By doing a science project, you will be learning about science in a fun and interesting way, and you'll also learn how to do experiments and solve problems. The hardest part, though, will probably be deciding just what to do. Start by picking a general topic in science that interests you. Then find out as much as you can about your topic. Look in library books or encyclopedias, and finally narrow down your general topic to one specific question or problem that you want to answer. You should choose a problem that you think you can answer by doing an experiment. Write down what you plan to do to find the answer to your problem. Before you begin your experiment, check with your science teacher for approval. He or she may even help by offering suggestions or materials that you can use. Your question or problem doesn't have to be difficult or involved. In fact, it can be something quite simple or even trivial that might be fun to do. For example, you might wonder how much gas is in a Bic lighter, or better yet, which brand of lighter contains the most gas. You might experiment to see how constant the temperature is inside your refrigerator, or how accurate the temperature knob is on your oven. Or even, how much time does a parking meter really give us? Are they all the same? You may prefer to do a product comparison experiment. The student that did this project is comparing laundry detergents. This type of project is not a survey, but rather a scientific study that shows which brand is best. The girl that did this project tested 3 different brands of diapers and found that Huggies absorbs and holds more water than Luvs or Pampers. You can test paper towels for strength or absorbency, or find the cost per hour for different brands of batteries. Brian tested candles for his science project.
I made a science fair project to see which candle was most cost effective. I took 4 candles and made 3 burns of each one of the candles to see which one would cost the most money and which one cost the least money. And I found that pick and save candles were the best candles to buy because they costed the least, and for the amount of money to buy one of the wicks and sticks candle right here, you could burn pick and save candles for over 80 hours.
My name is John Pensali. I'm from Meadowbrook School, and I did my science project on skateboard wheels to determine which ones perform best on different surfaces. I tested the hardness of different wheels by using a durometer tester, which is an instrument used to test the hardness of different plastics. And then after that, I took them and I rode them on different surfaces to see which ones performed better and which ones wore down quicker. I tested 18 different sets of wheels, and I found that the Sims street wheel was the overall best wheel. I got my idea for this project by starting in competition, and I wanted to know which wheel I should use and which one wore best, and I figured that this could help me edge out competition.
Evan investigated different types of light bulbs. He partially immersed them in water and measured the temperature rise in 15 minutes. With this information, he was able to determine how much of the electricity was used for heat and how much was used for light. Then he compared the price of each bulb. Which do you think rated highest, the energy saver or the soft white?
The soft white was $1 a piece. The long life and energy saver cost twice as much, but they only save a little bit more energy or last a little bit longer, so that doesn't make up for the cost.
So you recommend when people buy light bulbs, they buy what kind of bulb?
Well, fluorescent if they can, but there are some features of it that make it hard to use, like the unusual shape, so it doesn't fit in most fixtures. Plus it costs $10 and it might not be available in all stores. So if you can't get a fluorescent, I suggest a soft white.
How long have you been doing science projects?
This is my first year.
First year. You didn't do one when you were a 7th grader?
No.
And you won a first award, that's right?
Yeah.
Were you expecting that?
No.
What does it feel like to be a first place winner?
Great. I thought that when the third place awards were over, then my chance was gone.
Lisa is an 8th grader. She got interested in solar cells and wondered if you could get more electricity from a solar cell that was heated or cooled. She placed 3 solar cells around a light bulb, making sure that they were all the same distance away. One cell would be sprayed with Freon, a very cold chemical. Another would be heated with a hairdryer, and the third is what is called a control. This control is neither heated nor cooled, but gives Lisa a standard for her comparisons. Using the switch and the meter, she can read the voltage on any one of the 3 cells.
My name is Lisa King, and this is my project. I was trying to figure out if you can get more electricity from a cold solar cell or a hot solar cell. This is a solar cell that I used Freon on that got to about 65 degrees below zero. And this is the solar cell on hot that got to about 80 degrees Fahrenheit. I'm going to show you how this works. This switch turns on the light bulb, and this is turns on the meter. When I turn the blow dryer on and I switch this to hot, I'll see what the voltage is. The voltage goes down. Okay, when I switch the switch to cold and spray it on the solar cell, the voltage should go up. I had found out that the coldness on the solar cell makes the voltage go up, and the heat on the solar cell makes the voltage go down. And the ambient temperature solar cell is right here. It's just a test. And that's about it.
Mark did this experiment. He investigated factors that cause avocados to turn brown. He took this photo immediately after slicing 3 avocados. This control photo shows what the avocados look like before anything happens to them. He took another photo 3 hours later. The ripe avocado seems to brown the most, and the green avocado the least. He also noted that the pit doesn't seem to slow down the browning process. Mark continued his experiments and found out that lemon juice slows down the browning process, ascorbic acid prevents it, and heat increases it. This experiment was done to find out how height affects the shape that droplets make when they hit the ground. The control group consists of drops placed directly on the paper. Various heights were tried, and then the pattern of each drop was examined. What do you think the student found out by doing this experiment? Sometimes you might do an experiment only to find out that you can't answer your question. Desiree tested many snails by placing them on the center spot, then reading which color they moved to. In an experiment like this, it is important to test a large number to be sure of your results. She found out that snails really don't prefer one color over another. This is a perfectly good conclusion. Candy investigated the differences and similarities between chicken and frog embryos.
Hi, my name is Candy Avila, and I attend Computech Middle School in Fresno. What I wanted to do in my project was compare chick and frog embryos during their developmental stages in embryogenesis. I observed the differences and similarities physically, and also I did it with research. I used about 5 books.
What got you interested in this topic in the first place?
Well, the thing about them is that they are so unique. The final product is so unique that I wanted to see if they looked similar during their first stages of embryogenesis, since all embryos almost look alike during embryogenesis.
And you were telling me that a chicken has gills too?
Yes, it does. They change into other facial parts, but they do have gills during the 3rd or 4th day of incubation.
Would you say that you probably know more about chicken and frog embryos than maybe 99% of all the people in the world?
Probably. I think I know a whole lot.
And you spent a lot of time on this project,
I
right?
did.
How did it affect all your social life, like dances and parties and that type of thing?
Well, I tried to go to both, but it was kind of hard because I had to spend weekends and holidays doing my science project. And I had to spend time after school, so it was kind of complicated.
You still think it was worth it and you do it again?
Yes, I do.
Very good. Thank you very much. Jun built a high-speed centrifuge and spun plants in it for 3 weeks. His control plants received the same amounts of water and sunshine, but were not spun around.
Hello, my name is Jin Onuki. I'm from Elliott Junior High School, and my project is how do plants grow in increased gravity. What I did was just that. I found out how radishes and beans would grow in increased gravity, up to 15 times the normal gravity of the Earth. And to do that, I had to build this centrifuge, which spins around with the plants in these boxes. And these swung out because the thing was spinning around, and that generated the G-force needed, or G equaling 1 times the Earth's gravity. It went up to about 15 Gs on the very outer level, and the graphs here show the growth of each individual plant, 5G, 10G, 12G, 15G, and these are the different colors. Now you can see this is the control, and it grew a lot shorter and a lot slower than the rest of the plants did. And these are all the experimental plants, and they grew farther. And I would guess that probably if I continued the experiment, the control plants would have probably grown past the experimental plants after about 4 weeks of growth.
When you control variables, you are keeping everything the same except the one thing you are testing. The student that did this experiment used the same size containers and the same kind of soil. All the plants were radishes, and all were planted at the same time. Each plant received equal amounts of water and sunlight. Only the thickness of the plastic was different. Kelly performed an experiment in earth science. She investigated how different shapes affect erosion. Her control had no barrier at all. Since her setup was so large, she made a scale model to show at the science fair. She experimented with a curved barrier, a straight barrier, and an S-shaped barrier. By tilting all the boxes up, pouring water in at the top, and then collecting and weighing the runoff, she could tell which shape worked best. Kelly controlled her variables by using the same kind of soil and the same amount of water in each. All boxes were tilted to the same angle for each test. The only thing different was the shape of the barrier.
My name's Callie McClure. I go to Julian Junior High. I live in Ramona, and I did my project on a study of terracing and its effect on erosion. And it took me 2.5 months to produce the whole thing, but in study and research it took me longer. My results is my S shape. It turned out to be the best product out of my straight and my curved one. I did my experimenting by slopes, different slopes, and I found that at my 56-degree slope it eroded the most, and at 0 degrees it didn't even erode enough to record. I put my little figures back there, rain, wind, and ice, because that's the way it erodes in different ways. And basically I just did it on erosion because I have bad erosion problems in our backyard, and that's about it.
Hello, my name is Timothy Lane. I'm in 8th grade, and I'm from Bauer Junior High. And I conducted a study to see which water turbine could generate electricity the most efficiently. I used a rotor, which is in that picture there, to hooked it onto the shaft of my turbine, and from the wires that came out of that turbine, I hooked on my ammeter, which is a device to see how much electricity each turbine generated. I made various turbines. I made 4 turbines altogether. My hypothesis was that the Kaplan turbine this turbine right here would generate electricity the most efficiently because of the aerodynamics of the blades, the rectangular blades that were used in this turbine. I made sure that the cups or blades on each of the turbines that I had were exactly the same. I had 11 blades on each turbine, and the water pressure was exactly the same. I used a water hose, and the graphs here show the amount of electricity each turbine generated. The numbers on the bottom of the graphs tells how many times I tested the turbines. I tested each turbine 4 times to make sure that the scores I got were somewhat steady. I found out that the Pelton wheel right here generated electricity the most efficiently, and it was very fun being able to develop my own turbines and then test them out and see which one generated electricity.
Tim, incidentally, returned to the fair the following year with more data on water turbines and even different results from his early experiments. Let's look at some more project ideas, this time by category. In life science, you could find out if goldfish will grow more in a larger tank. Or you could determine if mice preferred the light or dark path. You could find out how acid rain affects the germination of seeds, or see if a pyramid really helps to keep bread from molding. If you try this one, don't forget your control samples. In physical science, you could find out which type of metal conducts heat best. The student who did this stuck tacks under each bar with grease and then recorded the time when each tack fell off. This experiment studies how fast water travels inside different tubes. The diameter of each tube is the same, but they're made of different materials. What about this one? Which tennis ball will bounce higher, a hot one or a cold one? You could choose a project in psychology. This experiment studies the relationship between the phases of the moon and various events, like emergency room use or the birth rate of children. The student that did this project wanted to find out if people would really follow these signs over a payphone. Would you? Here's an interesting one. Heather took pictures of many people. Each person then had to look through all the profiles and try to identify theirs. She tested boys, girls, men, and women. Which group do you think was best at recognizing their own profile? Your project could be in mathematics or computer science. You might write a unique program or make a robot that you can control with your computer. If you do a project in engineering, you may be experimenting with a new design or invention that you made. Scott made a robot arm with a delicate sensor that can even pick up an egg without crushing it.
I've always been interested in robotics, and this is my first time in the science fair, and I've sort of been building it kind of all my life in my head, but the science fair just gave me a chance to get it finished off and fix it all up, make it work perfectly for everybody. And
so this is the accumulation of your robotics experiments?
Yeah, this is sort of my final copy.
Have you started out with some simpler ideas?
Yeah.
Where did you get all your parts and things from?
I take apart stereos and dig in trash cans and look for stuff, and I go to scrap yards and get anything I can, any sort of mechanism, household appliance I take apart.
So I bet you can fix things too pretty good, can't you?
Pretty good, yeah. Cars I can't fix though.
Did it cost much money to put this together?
Not much, just a few things that are nearly impossible to build that you have to buy, like switches and things like that.
Now tell us a little bit more about what this one does. I see you're doing some egg crushing experiments.
Yes,
tell us about that.
I built a sensor so it could tell how hard I was pressing on an egg, and I tried to pick up an egg with a sensor one time, and I could tell how hard I was pushing on it, and so I didn't break it. Then another time I did it without the sensor, and it crushed the egg.
Sounds interesting. Do you see any practical applications for this project?
Yeah, assembly lines and building things and putting cars together and stuff like that.
Do you think you learned a lot by doing the science project?
Yeah, I learned a lot.
And did you learn a lot about solving problems? Did you have any problems with your robot here that you had to solve to get it to finally work?
I had lots of problems.
What was one of the problems?
Well, one of my main problems was making the arm move up and down. I didn't have a motor powerful enough to make it lift the whole arm plus whatever it was supposed to be holding in the claw at the time. So I found I had to move the string up farther to get more leverage as it pulled on the arm.
How much weight can it lift?
I'm not sure at all.
Have you done any weight tests with it?
No.
And how much accuracy do you have in moving it left and right?
Left and right is not that good. It doesn't move all the way to one side. That's because I'm using string and it's sort of stretchy, and it's not exactly perfect.
Very good. Are you going to stay with robotics next year?
Yeah, I'm going to build a bigger, better one with the onboard computer probably.
3 years later, as a junior, Scott returned to the science fair with his new robot arm.
My name is Scott Whitney, and I go to Kearney High School, and I'm currently a junior. I've always been interested in robotics ever since the 5th grade. I built my best robot arm in the 8th grade, and I took it to this science fair, and now I've even improved on that one, which I have right here.
What's the advantage of this arm over your previous model?
Well, before I was using fishing string for cables, and that had a tendency to stretch. This year I'm using steel cables, so it doesn't stretch and eliminates it from bouncing and jiggling around when it's come to the end of its path.
And how about different directions?
It has one more motion, which is bending at the wrist, which enables it to be able to pick up a lot bigger range of places, so it can get objects from a lot farther away and closer in than it used to be able to.
And how did your project do at the fair this year?
I got a first place, and I got 2 special awards from different societies.
How was the judging? Did you just have to demonstrate your arm?
Yeah, they came and asked me questions, and I just, gave them a little demonstration, told them about what I did, told them how I improved on the one I built in the 8th grade, and that's about it.
And how much do you have invested in this project?
About $20 to $30.
And simply, can you explain what some of the components are?
Yeah, I have here conduit piping that I've cut at various lengths for the skeleton. This is steel cable that I use to make it go side to side. This is the steel cable that enables it to move up and down. The motor in back controls that. This motor is what controls the wrist moving up and down. I purchased it for a few dollars at my hardware store. These are limit switches that tell it when to stop moving. See, it hits the limit switch and stops. If it didn't stop, it would keep on going, and it would eventually start to break cables if it didn't know when to stop. This is just another hinge out of sheet metal and bolts. This is my motor that controls the hand opening and closing. It just has a pulley that pulls around a wire and pulls this closed like this. The hand is actually a bike handbrake off a bicycle, and the fingertips are made out of sheet metal cut to the right shape and foam padding to help it lift objects.
Can you demonstrate it to show us how it picks objects up and sets them down? Very good. Do you plan to be back to the fair again next year?
Yeah, I plan to put one more degree of freedom, which would be a twisting at the wrist, and I'd also like to have it computer controlled.
Do you have any idea how you're going to get this twisting motion out of the wrist?
Probably just some sort of gear on a pivot with a motor connected to that, so it would just be able to spin around one pivot point.
All right, very good project. Thank you very much.
Thank you.
David, you did a science project on electromagnets to power vehicles. Is that right? Could you tell us a little bit more about it?
Well, I built a system where that using like the repulsion and attraction that electromagnets have, a car can be pushed around a track because it has like other magnets under it, and it's pulled and then pushed and then pulled over and over again to make it go around the track.
And how many electromagnets do you have under that piece of plastic?
I have 10.
And I think you have some permanent magnets in the car, is that right?
Yes, I have 3 sets of permanent magnets underneath the car.
How hard was it to build that?
It took me about 3-4 months to build.
Where'd you get the idea?
Epcot Center at Disney World, a General Motors exhibit which had this same sort of principle.
Where'd you get all the parts?
Just Radio Shack right down the street.
And about how much money is invested in it?
$10 at the most.
Now it's your turn. Spend some time thinking about experiments you might like to do. Be sure your science teacher gives you approval before you begin. On your backboard, state your question or problem. Make a hypothesis or guess as to what you think will happen. List your procedures. Present your results, and from these results, form your conclusions. Don't forget to allow plenty of time and use metric measurements whenever possible. Not only will you have fun doing your experiment, but many people can learn from your project. Perhaps even your science teacher. What about your sugar test? How many different things did you test with sugar? Just Karo syrup?
Sugar. This is the sugar test.
You tested all those things?
Yeah.
Which ones had the most sugar?
Karo syrup, wheat bread, white bread, marshmallow, apple.
So it looks like breads have a lot of sugar in them.
Yeah.
I didn't know that.
I didn't either.